This episode of Epicenter is brought to you by Jax. Jax is the user-friendly wallet that works across all your devices and handles both Bitcoin and Ether. Go to jaxx.io and embrace the future of cryptocurrency wallets. Hi, welcome to Epicenter, the show which talks about the technologies, projects, and startups driving decentralization and the global blockchain revolution. My name is Sébastien Couture.
And I'm Meher Roy. So today we have a really awesome episode for all of you. We are going to talk about Truebit, which is one of the truly visionary projects that I see in the ecosystem. So Truebit is a project that somehow scales the amount of computation we can do using smart contracts. And we are going to talk to the people who wrote the white paper for Truebit. They are Jason Teutsch and Christian Reitwiessner. So many of you would know Christian from his role at the Ethereum Foundation, where he leads the development of Solidity, Remix, and their formal verification effort. Jason has had postdoc positions at multiple universities, including NUS in Singapore, and we are going to interview the two of them today on their efforts at Truebit. So before we start, let's have a brief background about both Christian and Jason. Starting with Jason. Jason, tell us how you got into the blockchain space in the first place.
I think my blockchain story starts back in 2014 when Pratik Saxena, who is a computer science professor at the National University of Singapore, invited me to work on a research project with him. And I read my first research paper about Bitcoin as I was on the plane over to Singapore. He had given me a paper that he wrote called Power Splitting Games, which is about, it was a block withholding attack that sort of hurts Bitcoin mining pools. And I thought it had some interesting game theory in it, so I was sort of excited about that. And so I mean, of course, Pratik, before he came, he sort of mentioned the project that we were going to be. He had mentioned a project about sort of verifiable computing. So sort of, this is, people send tasks out to cloud. So there's this sort of cloud computing going on these days. You ask Amazon to perform a task for you, and Amazon comes back and says the answer is 47. Well, how do you know the answer is 47? Aside from just saying, well, I trust Amazon. I mean, can we do better than that? So, I started when I came into Singapore. We were looking at sort of, what sort of problems are easy to verify. Maybe they're hard to compute, but they're easy to verify. And one day I'm sitting in Pratik's office, and a graduate student walks in, and Loy Lu, he walked into the office and said, hey guys, there's a new cryptocurrency. It's got a Turing-complete scripting language. It's called Ethereum. It doesn't exist yet, but there's a guy, Vitalik Buterin, who's going to make it happen. And it didn't take long for us to sort of see verifiable computing meet blockchain. And that was really the birth of the consensus computer. What is the consensus computer is basically a way of making Ethereum smart contracts to compute certain tasks correctly, specifically those which don't require much verification. So you turn Ethereum into a sort of computer. So we wrote the first academic paper about Ethereum, and that was 2 months after I had read my first really found out 2 months after I had known what a Bitcoin was. So I was really a newbie here. We sent the paper to CCS, which is one of the major security conferences in the United States, and they rejected our paper. They said, this attack in your paper, it's never going to happen. It's just it's a bunch of theory. But of course, then during the rebuttal period, the attack, it did happen on the Bitcoin network. So that was the July 4th fork. If you remember, July 4th, 2015, there was a fork on the Bitcoin network, which was 6 blocks long. And the next day, July 5th, there was another one that was 3 blocks long. So our paper sort of predicted that, that failure on the network. And, well, they changed their mind. Our paper got accepted to CCS, and what can I say? We got lucky. So that was actually, that was the beginning of Truebit, although none of us really knew it at the time. So that's kind of how it all started.
And Christian, so you've been involved with Ethereum for quite some time too. Tell us about your background and how you got to be involved with Ethereum and leading up to this important time working on Truebit.
So yeah, actually I don't remember when I first heard about Bitcoin and blockchains, but I was observing Bitcoin, but never was really a part of it, and I always felt I was missing out on something. And then I was also always interested in this peer-to-peer stuff and decentralization and taking away the power from centralized entities and so on. And then I have a background in computation complexity. So the theory that talks about computation and resources needed for that. And so during the pre-sale for Ethereum, I heard about Ethereum for the first time, and I immediately felt, that's it. I have to do that. And so I joined in October 2014, and started working on Solidity. And I think so. How did I get to Truebit? At some point, I think it was the discussion about the. I think we'll get into that later about the Dogecoin bridge and how you can verify the Dogecoin proof of work on Ethereum. And I think it was a discussion with Vitalik, and we came up with this general idea, I think. And I think at some later point, Jason Vitalik met you at a conference, and he told you about that, right? And then that's how we got the connection. Vitalik said, "Oh yeah, there's this guy at this conference. He has exactly the same idea."
That's right. We were right. So I guess Vitalik put us introduced us together, and that the rest was sort of history. But I wanted to mention, in terms of my background, I'm a mathematician, and I think one of the things that was so really struck me, and was a game changer about the CCS paper. I never in my life had a time when a current event sort of directly impacted the research that I was doing. I mean, it's just sort of unthinkable in mathematics. We don't wake up in the morning and say, is the Pythagorean theorem going to be true today? I mean, does it depend on, anyway, I can come up with any number of examples. So for me, that was kind of like a real eye-opener, and it's sort of, and now, being in Truebit, I can't even imagine being, interviewed for the work that we're doing and stuff like this. It's tremendously exciting to see that mathematics can have an impact in the real world, and especially game theory. And
I could totally understand that. Here's at some level it sometimes feels like here's most of us just a bunch of nerds thinking about money, gold, nature of money, nature of computation, in your case mathematics, and suddenly with this technology it's all of our thoughts suddenly start to have real monetary impact. We would do things like this just as a hobby, but now it turns out our hobbies are worth in aggregate billions of dollars, and with us, episodes we make can influence the markets, right? Like recently we did an episode on Ripple XRP, and lo and behold, 2 days later everything else is down, but Ripple XRP is like up 25%, and we were like, what happened to Ripple XRP at that time? And it's almost as if, like, like things you do end up connecting to the real world in this technology in a strange way. So I think it must be similar for you on the mathematics side of it. So Christian, tell us like about your journey in Ethereum. Like when you started working with Ethereum, did you ever think it would be so big? Did have recent events caught you by surprise, or did you expect it to be so influential?
I mean, it was a gradual thing, right? So we always thought, I mean, the potential of this is huge, and we thought about, this might be used in the real world somewhere, and we wrote the code, and we had some of the early ideas and so on. But yeah, I mean, it's still not mainstream, so it doesn't feel like, I don't know, my parents using it. It's definitely, grew quite big, right?
So moving on to the topic that we're here to discuss, the Truebit. I have to say I've dabbled at the white paper. It's a very interesting concept on the face of it. Now I'm hoping that you guys can shed some light on how it works and what the use cases are. And so explain to us at the core, what Truebit is trying to solve as a problem, and then after we can go into how it's doing that.
Maybe we just start with what the problem is first. I think in order to say what problem we're solving, we need to sort of explain where we are right now.
Sure.
So smart contracts that are in Ethereum, so I'm going to sort of assume that people are familiar with what smart contracts are. They're basically programs that live on the blockchain. They're uncensorable, they're unstoppable, they do whatever they're programmed to do when they're first issued. So, but they have very limited computational capacity. I mean, you can't do anything more than very trivial tasks with a smart contract. And there's a gas limit in Ethereum, so that sort of gives a bound on the amount of computation you could do. So Truebit is a solution which basically allows smart contracts to do real computation like you'd expect on your home computer, for example. But let's get the elephant out of the room. Why not just wipe out the gas limit? That's the obvious thing. Then everyone can just compute whatever they want. But it's just simply not secure. So for one thing, folklore say, why can't smart contracts do more computation? A lot of people say, well, it's because everyone on the network has to duplicate everything. It's just too expensive, But that doesn't, that's very superficial level. I mean, you could always pay people more. I think so. If you scratch a little bit deeper, the real reason you can't do substantial computations over the Ethereum network is that you're basically asking the miners to do these computations for free. Now, everyone knows about transaction fees, but those only go to the miner that finds the block. But every miner has to now check these blocks. They have to check it for free, so they know which is the longest valid chain. And you're asking them to do it for free. Remarkable that they're willing to do anything for free. I mean, but they're willing to do a little bit for free. This is the sort of the amazing piece of Bitcoin and Ethereum that makes it work. And if you go back to the idea of the consensus computer, yeah, you can compute things that are trivial. But we had a piece there called what we call the verifier's dilemma. And what does that mean? So basically, you said, suppose a task came in that was actually difficult to verify. It took a miner a long time. So now there's this sort of incentive for a miner to skip the verification, right? So he could skip the verification. Well, that's bad because then you could get wrong things on the blockchain. But it's even worse than that because even though the miner can skip verification, if everyone else is also verifying, he may end up by skipping, mining on the wrong block. So then he doesn't. A rational miner doesn't even know whether to verify or not, right? I mean, because if everyone else is verifying, he better verify too, and if everyone else is skipping, then he has to skip. But there's for a very high computation, it's impossible to know what, miner wants to be on the longest chain because that's sort of the convention. But that's what the verifier's dilemma is about. Don't know whether to verify or not. So you can get all sorts of garbage onto the blockchain if you just ignore the gas limit in Ethereum. And not only that, but you could have denial of service attacks too, because people just throw stuff out there to waste miners' time, and they have finite resources. So.
If I could rephrase that, let me see if I'm getting it correct. So what you're essentially saying is that, so in Ethereum we have this analogy of the world computer, right? That a computer is basically a machine that is able to execute some form of instructions. And in history, like, we have implemented computers as these mainframes inside universities, as desktops, as laptops, as mobiles. And like Vitalik's sort of idea was that you could imagine a whole blockchain network as this computer that can also execute these instructions. It can, like, you can store data there, and you can basically do any kinds of computations on a blockchain network. And these computations are called smart contracts, and you can obviously also put data in these smart contracts. Now, if you start thinking of it as a computer, it can only do very limited amounts of computation. So I think somebody compared it to being like a smartphone, right? Like it can do a very little amount of computation. What you're saying is, like, what Truebit is trying to do is kind of scale it from just having the capability of computing equal to, let's say, a smartphone, to something maybe, thousands or millions of times greater, right? And the other piece you're saying is that what is the ultimate reason why Ethereum, the system, is only able to do such less computation? There you're saying that the reason for that is something called the verifier's dilemma, which is that if the four of us are miners in Ethereum, like spread around the world, and let's say one of us discovers the next block, so Jason discovers the next block, then Jason is paid for that block to include transactions and computations inside the block. But then there is no incentive for Christian, Sebastian, and Meher to verify that what Jason claims as the results of these computations are actually correct. Is that right?
Right, they don't get paid for it. So there's an incentive in the sense that if they don't verify, they might end up mining on the wrong chain and they won't get rewards, but they don't receive a payment for the verification per se.
Yeah, for Ethereum, it's also a bit different, because so at the point where you stop verifying, you're also unable to include new transactions yourself, because in Ethereum you have state, and you need to update that. And if you only have the Merkle root of the state, you can't really update the state. So if you stop verifying as a miner, you can't get fees from including transactions. But yeah, you can mine empty blocks. So that's still an option for you.
So tell us, what is the core concept behind Truebit? What are you doing, and how do you intend to do it?
So we have basically two assumptions on Truebit. One is that the consensus computer works. In other words, smart contracts can do trivial computations correctly, and this is just an empirical observation. We see Ethereum doing what it's supposed to do, and that's why people use it. The other thing is that we assume that people, participants are rational, and by rational means they're working individually to maximize their own personal profit in collecting Ethereum tokens or whatever Bitcoin happens to. Well, I guess we're really talking about Ethereum here, so let's just focus on that. So of course, the assumption of rationality is somewhat idiosyncratic. It's also somewhat pessimistic, because Satoshi Nakamoto said that the majority of miners are just going to be honest. And while that may have been true in the very beginning, when Bitcoin was getting started, and it was about the politics, and the people really didn't trust the government, and that's why they were there playing Bitcoin. But since then, we've seen, people switching from CPU hardware to ASIC miners so they can get more coins. Also, I guess we can't judge people's intentions, but people are switching hardware. We also see that miners joining mining pools, in effect changing the software. So my feeling is miners are actually in the network. They want to make money. I mean, that's sort of the assumption of Truebit. So how can we, given that most people are rational, how can we sort of take advantage of this sort of natural inclination that people seem to have? So those are the core two pieces, and we'll assume that we have this small thing that works correctly, and we want to blow it up. So we do this in two pieces. So first of all, how can you get a tiny computer, like a consensus computer, to even check a really hard computation? So we designed this game, which we call the verification game, which Christian alluded to earlier. That was what Vitalik heard about the verification game from me, and he heard about it from Christian. And for those of you who were around back in 2011, you might have heard it from Kennedy, Riva, and Rothblum, who published a paper with almost exactly the same idea. Of course, they didn't have cryptocurrency in mind, so it was really about a situation of cloud computing back then. But so what we do is you imagine that there's the consensus computer sort of acts as a judge. So you have one solver who says, here's the solution, and a verifier who says, no, it's not. So the consensus computer just has to adjudicate and decide who's right. Well, it creates a game in such that the judge only has to enforce the rules of the game, but doesn't actually have to do the computation itself. So in each round of the game, you reduce the sort of possible places where the error could occur. So the judge has to pinpoint the error, and eventually it becomes such a small piece that he can actually look at it and determine who was right, whether the challenge was justified.
So I'm trying to understand what a use case of this might be, and tell me if this makes any sense or not. I want to use a world computer, right? A distributed computer to do something like compile software. Like I want to compile the Ethereum Go client. Is this something I could do using Truebit? And if so, then how would I do that? And if not, where am I getting this wrong?
So that's a very interesting use case, and let me modify it a bit. So can I use Truebit to verify inside a smart contract that a certain piece of Solidity source code was compiled with a certain compiler into a certain piece of EVM bytecode? And that's definitely something that can be done with Truebit, and yes, it's one of the use cases.
Okay, because earlier we were talking about sort of this idea that you could, I don't know if this was pre-show or what, but we were talking about this idea that the model right now is you have, say, AWS, and you ask AWS to do some kind of computation that could be calculating some really complex formula, or doing some encryption, or maybe decryption, or maybe compiling software, or encoding video. As far as I understand it, Truebit is a way to do this in a distributed way, so that you don't have to trust Amazon, or you don't have to trust a central entity. And Ethereum does that, but it does that in a way that only is available for smaller computations and not large computations. So if this is the premise, then how does that port over then to Truebit? Or am I getting the premise wrong?
I guess one thing I'd sort of maybe like to clear up is that, as you pointed out, Truebit is a completely democratic system. There's no reputation. There are no upper class nodes. There's no federation or anything like that. It's in that sense it resembles Bitcoin in the way Ethereum originally was, and the way Ethereum is right now. And in fact, when an error occurs, it's also a different kind of consensus. It's not a majority consensus. We're talking about a unanimous consensus, right? So anyone on the network can challenge a solution before it hits the blockchain. Anyone can do it. And then they'll play this verification game. I guess the real trick, if you want to say, to getting Truebit to work is, how do you convince people to actually play the verification game? I mean, normally, if everyone knows that all the answers are going to be right, then who's going to be around to check the answers, right? I mean, if you get, for example, if you get a prize for finding a bug if you find a mistake in the computation, but you know that you don't have any reason to believe that mistakes will actually occur, then why are you wasting your time doing the verification at all? Truebit is in two parts. The first one is this verification game that we just discussed, and the second one is an incentive layer to convince people that they should participate in verification. The idea there is that we sort of force the system to occasionally create mistakes so that verifiers are actually going to look out for them and they have an incentive to participate that way. So you have we call this a forced error mechanism. So occasionally Truebit will create these forced errors, and then the verifiers should find those, and that should keep them available and interested in playing the game. And it also serves as a sort of a proof that the verifiers are actually verifying, because otherwise, how does the system know that anyone's checking the answer? That's the problem.
I think we need to go into the basic concept a little bit, right? Like, so imagine like this simple scenario. There's Sebastian, right? And Sebastian wants to run a smart contract that is going to consume 50 million gas units, right? It doesn't matter what Sebastian wants to do. It is something that is complex enough. Like, he wants to run a very complicated gambling lottery, right? It has a lot of rules, and in order to do some steps inside his gambling application, he needs 50 million gas today. So today, if you look at the Ethereum system, the gas limit is like 5 million or something, right? Which means Sebastian's transaction will never fit into an Ethereum block as it stands today, right? Now, what you're saying is, like, Truebit is a solution that Sebastian could use to have a smart contract computation that can run in enough steps to consume 50 million gas, right? Now, how would it work? How would Sebastian get his computation or transaction that consumes 50 million gas into the blockchain? Like, what does he need to do, and who are the players that allow Sebastian to do this?
Truebit itself is a smart contract in Ethereum. That's what it is. It takes that form. So it's I guess you can think of it as a smart contract that can be called by other smart contracts that need additional gas. And then this Truebit smart contract, if you will recruit the other parties needed and incentivize them properly to make sure that the output of that contract is the correct answer to the query that came in. I mean, the main parties you have there is that you have a task giver, who's the one who sends in the task that needs to be performed. You have a solver who's going to provide an alleged solution, and then you have a verifier who's going to make sure that alleged solution is actually correct. And then you also have the miners who function as judges and referees to make sure that they play by the rules of the game without actually doing the computation themselves. And those are the players.
So normally when like a computation happens on Ethereum, computation is triggered by a transaction. So for example, I create a transaction, and that transaction like triggers a computation, and then there's an output to that computation, and I broadcast this transaction to the miners, and the miner that includes my transaction in the next block has to make the computation, and all of the other nodes have to verify that computation, right? Now, in this case, what we are doing is, when I create a transaction that like triggers a very large computation, the blockchain sort of outsources that computation to an individual solver. Am I reading that right? That instead of all of the nodes of the Ethereum network needing to do that computation, they're going to outsource that computation to a particular solver, which is like an individual machine. And in order to ensure that the output of that individual machine is correct, there are going to be other verifiers that are going to verify that that output is correct. And this game between solvers and verifiers is going to ensure me, the user, that the output given by the system is correct.
So this is not something which needs to be implemented as part of Ethereum itself. So nothing in Ethereum itself changes, and so that's why I wouldn't use the term transaction. It's just, so Truebit will just be a smart contract which people can use by calling its functions. I mean, in the end, of course, you send transactions to that smart contract, but it doesn't automatically, so as part of Ethereum, we don't automatically outsource this computational tasks. And the forms of these computational tasks are also different than what you currently have on Ethereum. So you don't have the Ethereum virtual machine, for example. We plan to use a similar thing, but a different virtual machine. And it's also important that, I mean, that's kind of an implementation detail, but the tasks that are to be performed have to be kind of pure functions. So you don't directly have access to the blockchain or things that are available in Solidity like MSG.Sender and all this stuff. You can make that available via Merkle proofs to the blockchain, which are easy to verify in the in such a Truebit computation, because you have a lot more gas in quotes available.
So I'd also like to add that, clear up the roles that are being played here, that anyone can participate in the network, anyone can choose to be a solver. The way that the protocol is we designed it is that, essentially there's a lottery that chooses who gets to be a solver, but anyone can always verify. And of course, the more the merrier. The more, we only need one verifier, but if you have more, it doesn't hurt. So, but these solvers and verifiers live off chain, and really the only thing that sits on the blockchain itself is the enforcement of these rules of the game.
Let's take a short break to talk about Jaxx. Jaxx is your wallet, your complete user interface to cover all your blockchain needs. I've been using it and I've been loving it. Now, Jaxx supports a lot of different cryptocurrencies. It supports Bitcoin, Ether, Litecoin, Ethereum Classic, Zcash, Augur Rep, and they're adding many more. Keep responding to users' needs. Now, with Jaxx, the nice thing is that you can manage all of those coins within a single wallet, and you are in control of your own private keys. They're not on their server, and there's a single 12-word seed that you can use to back up your wallet, all your coins, and sync them across different devices. Talking about devices, they're on pretty much any device that you can think of. You can get it on PC, Mac, Linux. You can get it on smartphones like Android and Apple and iPhone. You can get it on tablets, or there are even browser extensions for Chrome and Firefox. And on top of that, in Jaxx, you can actually exchange different cryptocurrencies for each other, because they've integrated a Shapeshift. And more partnerships and integrations are coming down the line in 2017 that are going to make Jaxx even better. So Jaxx is really making blockchain and cryptocurrencies accessible for the masses, easy to use for the masses. Make sure to get your own Jaxx wallet at jaxx.io, or you can get it from any of the app stores you are using. We'd like to thank Jaxx for their support of Epicenter.
Let's define then what is so there's different participants, right? There's a task giver, the solver, the verifier. I think there's a challenger too, or let's
define each of them. Like, who is a task giver, who is a challenger, who is a solver, who is a verifier, and what do they do?
So you have the task giver, which basically specifies the function to compute, the program to execute, and the input.
So the task giver is the one who sends the smart contract to the blockchain.
I wouldn't call it a smart contract. It's just a program to execute.
Okay.
It can be a smart contract, but it's just a program to execute. And the task giver also pays for the task giver also pays for the whole thing, right? So you pay a fee. And then a solver actually performs the execution. runs the program and then posts the result onto the blockchain, just the result. And then verifiers can basically do the same thing as the solver, just rerun the whole program and check whether they come up with the same result. Nobody's forced to do that. So and verifiers can also come in from outside at any time and just rerun these programs. And if they come up with a different result, then they can challenge the result. And that's
I see. So the
the point
verifier
where the
then becomes
verifier
the
turns
challenger.
into the challenger.
That's a bit clearer. Then once the solver has produced the results, and you want to have verification. So as the task giver, I want more than one verification attesting that this is in fact the right result. So I may have one verifier that produces a verification, another that produces a verification, and maybe I have like 5 or 6. And at which point, as a task giver, can I be sure that, or have enough certainty that my computation, the results of my computation as provided by the solver, is accurate? And is there an incentive model there that starts to drop off? Because I suppose then the solver and the verifiers get paid for all of this. If I'm the 1,000th verifier, does it even make sense for me to participate in this verification?
So this whole thing has an interesting property. So the verification game is always will always find out who is right and who is wrong. Okay, and this is all deposit based, as in other. So if the solver posts an incorrect task, the solver will be punished. So this whole system should already work, even with just a single solver, without any verifier. But you just so that as long as the task giver knows that the solver thinks that someone is verifying. So there doesn't have to be an actual verifier out there, but we designed the system in a way that it's extremely likely that there is a verifier out there and the solver knows that.
So the verifier, okay, I see that. So the solver is providing a response and is incentivized, because he's putting a deposit, he's incentivized to provide the right result, because a verifier may verify it and prove him wrong and then therefore get the deposit. Mm-hmm. I see. Okay. How is there like a time period? Because perhaps as a solver, I provided a bad response or a bad result, and then I get my deposit. I get the deposit, and then 3 weeks later, someone discovers that I was actually wrong. How does that play out?
So yeah, I mean there are timeouts. So this whole thing consists of multiple rounds, and there are timeouts in each round. And sure, so if the system fails in the way that the solver can post an incorrect answer and nobody challenges this, then it will not be detected. So at some point you have to basically finalize the result.
Right.
And you could build a different system where you can challenge again even after a long time, but that's probably not going to work out.
It's starting to become clearer now. I see. So coming back to my original question, what types of computations are likely to be run on this? Like when you say I want to run this computation, and it's not a smart contract, it's code going through this smart contract that handles this deposit and the verification and the solving and all that, providing the proofs. Can I throw at it like C++ code or whatever, like in Go, or does it have to be in Solidity? How is it packaged? Like how does one send that payload onto the blockchain?
Yes, we want this to be usable as nicely as possible. So we want regular programs to be run there, which means, programs written in C++ or Go or Python. And because of that, we chose, that's the goal. And the requirement is that we need some kind of architecture that can be easily implemented on the Ethereum virtual machine, because the blockchain, the Truebit smart contract, needs to verify this single step. And in the end, you have to implement, so it's a single step on some machine, and in the end you have to implement the full logic of such a machine. And it turns out that there is an architecture called Lanai, and this is something developed by Google, and I think nobody really knows what they actually use it for, but what they did is they built a backend for the LLVM compiler. So it is possible to take C++ code and Rust code and whatever LLVM can take as input and compile it into the Lanai architecture. And from that on, the Truebit contract can verify it. So this means that, you will be able to verify any programs at least written in C++ and Rust. And you can also go a step higher, because we don't really have a gas limit, and run programs which are written in a programming language that has an interpreter written in C++, for example. And Python is one of these.
So I have one last question before we go to the next topic, which is what applications can we use this for, and that is I guess the non-deterministic nature perhaps of some of these languages. So I have some understanding of computer science, but I'm not a computer scientist. But maybe this doesn't make sense, but I'll throw it at you anyways. I, as a task giver, send some C++ code to be solved by a solver. It's my understanding that, maybe on my environment, if I run this, I'll get one result, and another environment may get some other result, and the formal verification languages somewhat address this issue, or perhaps address this issue fully. So for these languages that we cannot formally verify, is there a risk that a solver may, in good faith, provide a result that was valid on his system, but maybe not valid on mine, or maybe like a verifier checks it and it doesn't check out? Does that question even make sense? Or
sure. I mean, that's what the Lanai, that's what Lanai is for. It's to make it all standardized, so that the Lanai interpreter will exist also on the blockchain, the full code. So
okay, so standardization was where I was, I guess, trying to address here.
Critical, absolutely critical.
I think we'll ramp that up in stages, where we first start with only specific tasks, and then we allow arbitrary tasks when we see that everything works out. And so the thing is that when the solver executes the task, then the solver will probably not run the Lanai interpreter, so go all the way down in the stack to the final architecture, because of performance reasons. So the idea will be that you take the C++ code and compile it to your native machine, run it there, and then you get a result. And of course, it might be that this result is different if you compile it all the way down to Lanai. And so in this situation, we might have a fallback where we don't have to play and the verification game will be played on the Lanai level. And so the solver, when we start the verification game, then the solver would notice, oh yeah, I get a different result. Sorry, my bad, or something like that. But yeah, so the tasks that, I mean, in the end, it's a consensus computer again, right? So the tasks that are given should be deterministic and should be, mathematical functions, so to say, which always yield the same result.
I'd like to add to what Christian just mentioned about, the mistake on to say we have to fully trust that the Lanai interpreter is going to interpret the programs correctly. And this could be an iterative process. It's obviously Lanai is a new program as well, but the good news is the entire Lanai interpreter is sitting on the blockchain, so it's fully transparent. We can issue a new contract. Everyone can inspect the code. It's not like sending it into a cloud computer on Amazon, where you don't see the hardware, you don't see the software. They may tell you what it is, but you can't witness it in the same way that you would be able to do on a Truebit computation.
Okay, so we have walked through the idea of there being like solvers, verifiers, and the combination of solver, verifier, and challenger, ensuring that the result of a particular computation in Truebit is correct, right? So now, like assuming we have this system, we have Ethereum, which is the sort of base layer, and then we have this other layer, Truebit on top, which allows us to scale computations on, like scale ownerless computations in a way, right? Like in Ethereum, you have computations that are not owned by anybody, and they are guaranteed to be correct. And we are able to kind of scale these sorts of computations using Truebit. So like once that happens, what are the sorts of applications that open up?
Well, I guess we could say there are many. We've also had several people suggest applications to us. As Vitalik used to say, the best application for Ethereum is the one that I haven't thought of yet. And I think the same could be said true for Truebit as well. This is really, we're talking about a community project. The abstract machine itself is not an end, but a means. So let's start with the obvious application, outsourced computation. So Truebit, I guess we should clarify when we say outsourced computation, we're not competing with the Amazon cloud in the sense that it's expensive to run a Truebit computation, and the security of the system may degrade as for truly extremely large computations. Of course, in the long run, we hope to optimize it for we believe that there are optimizations possible that can push it further, but the first goal is to get beyond the trivial computation of what can be done in smart contracts now and then push it further. So there are several other projects. As Christian mentioned earlier, the Doge Ethereum bridge was an early inspiration for this project. I mean, what the Doge Ethereum bridge would allow is Sheebs, the Dogecoin users, to take their Doge and basically send them off the Dogecoin blockchain onto the Ethereum blockchain. Truebit would check the Dogecoin script proof of work to confirm the transfer. So that's the reason we need Truebit. And then there would just be some sort of token on the Ethereum network that represents a Dogecoin token. You could use that to in a smart contract, and then sometime when you're ready, you just send that token back to Dogecoin, and it's a Doge again. So
then Ethereum is sort of a side chain to the Dogecoin chain. Is it, so you send the Doge to an address that there's a computation that verifies that the coins are there, and then they get issued as a token on Ethereum.
Right. So once you send it over to Ethereum, it's sort of Dogecoin destroys the coin, and when you send it back from Ethereum, it annihilates the token. So it's that's how the process would work on the high level. But you can imagine that you can imagine that if Dogecoin, for example, if Dogecoin wasn't the only one that wanted to send coins to Ethereum, you could have other blockchains also doing this, sending their coins and turning them into tokens on Ethereum, and then you could exchange them. You don't need a third-party exchange to switch those tokens. So what's needed in order so I think in order to export your tokens to this conglomerate system, if you will, in order to export, you just need to make some opcode in your system that says export across the bridge, the token, the coin. And if you want to be a hub that imports them, you need to have some sort of smart contract functionality that can, as Ethereum does, verify the proof of work for that other chain. So anyone can be a hub, and anyone can be a participant. So obviously, being a hub is slightly more involved because doing smart contracts is a big deal. But that's how
it sounds very similar to another project that is about to do a crowd sale, for which a host of ours perhaps works there. It sounds very similar to Cosmos. I mean, what you're describing, basically.
Except with a very different architecture. So,
right. So the architecture is different, but the functionality and the use that you get out of it is essentially the same.
Basically, coins that effortlessly move across blockchains. So you could have like hundreds of chains, and the coins of one chain could go to another, do something there, and then come back like that, right? So this would make all blockchains sort of interoperable. I don't know if that's the correct word for it.
I think that's fair. I mean, one difference with Cosmos is you sort of, as my understanding from watching your video, is that in order to participate in Cosmos, you sort of have to delegate responsibility to a set of validators who are going to execute these exchanges for you. And in Truebit there are no upper class nodes. There's no hierarchy. It's purely democratic. We are organic grassroots organization. Anyone who wants to build a bridge can build a bridge, and anyone who doesn't want anything to do with the bridge can do their own thing. And you don't have to sort of decide whether or not to delegate your authority to this giant conglomerate that's already out there. It's just an agreement between two people, which is, I don't know. That's the idea. Not two people, two communities. Let's say it like that. You got it.
Okay, so I think that's a very big application, right? So you're saying that so the one blockchain can verify what has happened on another chain using by delegating this task of sort of verification to Truebit, right? And what are some other applications for your system?
So another one is I think a storage solution. As you can grab information from other blockchains, you can also grab from, say, Swarm, which if you have a place where you can permanently store information, so just in general, whether it's on a blockchain, whether it's on Swarm, Truebit can sort of use that. Solvers and verifiers can access that information in their computations. Maybe you import a Merkle root of whatever the data is that you want to use in the Truebit computation, and it's accessible.
Could one think of building? So we've had Marley Gray from Microsoft, who told us about Bletchley and Cryptlets, and what Microsoft is doing now. Not to get into too much detail about that. Well, they're using Intel SGX, or the idea is to use Intel SGX hardware, which allows the proof computations to do this, right? So you can delegate a computation to a trusted execution environment to do some form of computation, or to retrieve data from a feed. So you could have some sort of an oracle that is retrieving data from, like Bloomberg, and with TLS Notary, you've got the certainty that that data feed is in fact coming from Bloomberg, and then that Cryptlet, which is a trusted execution environment, is feeding that into a smart contract. Is this something that would be possible with Truebit to build this sort of oracle that is verifying a feed and providing it to a smart contract as an oracle?
Yeah, so I think that doesn't really fit the Truebit model. So one of the essential requirements for the verification game to work is that a Truebit smart contract needs to ensure that all solvers and all verifiers have access to all data that is involved. And this can be done on Swarm, because on Swarm, at least in the final version, we will have these storage certificates. And because of that, you can use Swarm as so Truebit basically creates the driver, the file system driver, to add Swarm as a file system to Ethereum. But it doesn't solve the Oracle problem, because you have...
Okay.
Yeah.
So because it's not deterministic.
Yeah, it's not a function that maps inputs to outputs. Yeah, exactly.
We also read there were some proposals to use Truebit to build decentralized mining pools for Ethereum itself. So you'll use Ethereum to build Truebit, and then Truebit would be used to build a decentralized mining pool for Ethereum. Like, tell us how something like that would work.
Smart Pool is a project that I was involved in from the very beginning. I am a co-author of the Truebit Whitepaper, along with the people who are actually building Smart Pool, Loy Liu, Yaron Vellner, and also Pratik Saxena was a co-author on the whitepaper. Basically, Smart Pool is a mining pool where the operator for the pool is an Ethereum smart contract. Now that can be a pool for Bitcoin, it could be a pool for Ethereum. Of course, it's very cool if it's a pool for Ethereum because the smart contract is on Ethereum. And originally I thought they would, I was sure they were going to need Truebit to build out the Ethereum version of because of the way of smart pool, because of the way that it's hard to check an Ethereum proof of work. It requires a lot of storage, as opposed to Bitcoin where you could sort of do it right away. But due to some, I guess I would call it a fluke a coincidence in the construction of the Ethereum proof of work, Smart Pool found a clever way to do it without that. I don't think they're going to need Truebit, but Truebit may be useful for other checking other proof of works. For example, Dogecoin or Zcash, which are maybe just out of reach of what smart contracts can do. So I mean, the smart pool application is interesting because if you have a pool operator who's managing the contract, there's no censorship. You can run it at a low cost. There's no social contract. You're normally there's a sort of social contract between members of the pool and the miner that they get paid and so on. The smart contract sort of enforces that. You also have, there are other sort of decentralized pools out there like P2 pool, but they have higher variance, which sort of negates the purpose of joining a pool in the first place, the payout variance. And of course, it's retrofitting. You don't need to make any changes to the blockchain itself. So I mean, smart pool is sort of an interesting potential application for Truebit. I would say that.
Cool. So before we wrap up, tell us what's the state of the project right now, and what's the roadmap? Where do you plan to take this? Is there like a release, or some sort of are you planning to build a company out of this? So tell us where you're taking this.
Well, actually, before I answer that, I wanted to mention sort of, if I may, one other application which may be very interesting. I know we talked about
Sure.
sort of that Truebit is a connection between the blockchains along the lines of Cosmos, but I think we want to be not only the connection between the blockchain of blockchains, but as we say, but the glue between blockchains, but also the glue between blockchains and the real world. So as an example of this, there's one project that's very interesting by Doug Pitcanix and Eric Tang called LivePeer, which is live decentralized streaming video. So they're basically going to use Truebit to do the broadcasting coding. So I guess you could imagine YouTube without the YouTube. As you know, it's expensive to do live broadcasts of sporting events and things like that. So that's something I think that where we see this technology can bridge the gap between cryptocurrency enthusiasts and really bring the technology home to your everyday people who can use it. So
I mean, this is also similar to with LivePeer. Basically, you outsource the actual compression of the stream, and and I don't know, Golem and these other projects do a similar thing for other tasks, for other computational tasks. And for all of these, Truebit can be the mechanism that ensures that the computation nodes just don't do anything but do the actual tasks that they are supposed to do.
All right, so then let's come back to the previous question. What is the state of the project, and where do you plan to take it?
So we are in the process of turning this white paper into a reality. We want to make it available to everyone. It's partly built out, but we're not ready to release it to the public yet. So it's a fairly ambitious and experimental system, and of course it will require a fair bit of testing too, because some of the parameters and so forth depend on human behavior and things like this, which we want to test our assumptions of rationality, but as we say, it's not. This isn't a type of project where you can't prove it by mathematics. The proof is when it actually works in the real world. So that's the next step, is to get it out. And we're right now in the process of connecting with people who want to use this technology, and we encourage people with good ideas to get in touch with us and let us know how you want to use Truebit, and possibly what features you'd like to see in the next version of the programs.
And if anybody wants to help, participate in any way and get involved, how can they do that?
Right. So right now we are actively looking for funding for the project, and we're looking for people who can help us develop. So if you want to do either of those things, we're please get in touch with us.
Will you do an ICO of any kind to raise funding here?
ICO is a possibility for us. We don't have an immediate plan for an ICO.
So in theory, like how would an ICO model work? So I understand the funding part of it. So there'll be tokens, people will buy them, they become stakeholders. But once the system goes live and people start delegating these computations, how do the token holders get compensated, or how do they earn a profit on their investment once the system is live?
Well, first of all, we don't consider this an investment because it would be a product. As a product, if you wanted to, for example, we don't have a specific structure in mind, but solvers could get paid for performing tasks, and task givers could pay for having tasks they want to have performed. So anyone can participate, and regardless of what currency is used to do the actual transactions. That's how the system would work. It's an outsourced computation model. You pay for computation time, and anyone who wants to offer CPU cycles can get paid for doing so.
Okay, great. Well, thank you so much for coming on the show. It was a pleasure talking to you guys and learning more about Truebit. I have to say, I have a much better understanding of it now. It makes a lot more sense, and the use cases also are a lot more clear. So we'll be looking forward to seeing where this project, how this project evolves, and wish you a lot of success.
Thanks a lot.
Yeah, thanks a lot for having us.
So thanks again for coming on, and thank you to our listeners for tuning in. We are part of the Let's Talk Bitcoin Network, soon to be the Let's Talk Network, but still the Let's Talk Bitcoin Network. And so you can go to letstalkbitcoin.com to find this show and a lot of other great shows. You can also support us by leaving us an iTunes review. That helps others find the show. And also, if you're interested, you can give us a tip. Our tipping address in Bitcoin and Ether are both in the show description. And so yeah, we'll be looking forward to being back next week.